Yes, sir.
Yes, sir.
Yes, sir.
That's what we are interested in. Okay. So, how do we go about doing this? Can anyone tell me what is the ratio of area of triangle PAB and triangle PXY? What is the ratio of area? You can raise your hand and unmute yourself and tell me. Okay, Anjali, tell me what you have in mind.
Sir, is it AP is to XY?
Excellent, Anjali. You are right. It's AB is to XY, which is the ratio of their bases. Ratio of bases. And if some of you are not sure why it is true, let me
Yes,
quickly,
because
yeah, tell
so
me.
it is because perpendicular drawn from P will remain same, sir. So it just remains at the bases, the ratio to bases, sir.
Correct. So if PT is the perpendicular dropped from the point P on the line L, so this is the line L. So this is the height of both of these triangles. The height of both of these triangles. So let's call this height H. Let's call this height H. So the area of PAB is half H height into AB, and area of PXY is half height into XY. So if you take the ratio of it, if you take the ratio of the two areas, then you can cancel off the half, cancel off the H. So you have AB over XY. AB over XY. This is a very simple principle. I am pretty sure most of you know this. There is an associated principle. Yes, Pemadi, go ahead. What you have? You have a question? Pemadi, do you have a question? Okay, maybe not. All right, there is an associated principle, an associated principle, and this is about ratio of areas of similar triangles. Of similar triangles. Again, some of you may already know this. That's totally fine. Let me quickly tell you about it because we will be doing some really interesting problems based on these ideas. Okay. So the ratio of areas of similar triangles. So suppose we have a triangle ABC and we have a triangle which is similar to ABC. Let's call it XYZ. So can anyone tell me what is the meaning of similar triangles? Can anyone tell me what do I mean when I say ABC is similar to XYZ? Okay, I see some raised hands. So let me go to Raghav Mukheja.
So similar triangles is actually when the angles are equal.
Okay, so
So
you're
of
saying it's equiangular. Maybe angle A is
exact-
equal to angle Y. Okay, maybe. Okay, I'll just write it like this: X, Y, Z. Angle A is equal to angle Y, X. Angle B is equal to angle Y, and angle C is equal to
also
angle Z. Okay, maybe that's the
right,
case.
also they have the same shape.
Okay, let's ask Shoham Bhadro. Shoham, what do you think? Okay, I cannot hear Shoham. So let's go to Ashutosh Rathod.
So maybe both of the triangle have the same dimensions.
Okay, that
Sir,
is not right.
sir,
Let's go to, wait, let's go to Nilabho Shom.
Yes, sir. So, sir, two triangles are similar to each other. If we can superimpose one triangle onto the other by using scaling and rotation.
Okay, that's a good idea. You pick up a triangle, you place it on another one, and you stretch a little bit or contract a little bit, and you get the other triangle. That's what Nilabho told us, and it's a very good idea. That's right. Shoham told us something in the chat. Shoham told us something in the chat, which is also very interesting. He's saying that the sides are proportional. Side, what sides? What does he mean? So perhaps he means like this, that corresponding sides are proportional. So what are corresponding sides? Well, there are equal angles, as you mentioned. So the side opposite to angle A and the side opposite to angle X, they are corresponding sides. You take two equal angles, you take the sides opposite to them. These are the corresponding sides. So BC over YZ, you have to take this ratio. Then you take the side opposite to angle B and angle Y because they're equal. AC over XZ. Then you take the side opposite to angle C and angle Z because those two angles are equal. AB over XY. So these three ratios are equal. That is the meaning of the statement that corresponding sides are proportional. Okay, so it seems to me, at least, some of you are telling me that the angles are equal. So the equiangular thing. Equiangular thing. Some of you are telling me that. Some of you are telling me that corresponding sides are proportional. Some of you are telling me you pick up the triangle and you place it on another one and you stretch or scale it to get the other triangle. If that happens, then they're similar. So are these definitions equivalent? That's my question. Can anyone tell me if the corresponding sides are proportional, then should the triangle be necessarily equiangular? Again, if it is equiangular, then is the corresponding sides proportional? Yes, Gaurav Chandrasekhar, tell me what you have in mind.
I don't think so, because like the angles can be different, but the sides can also be proportional.
Okay, Shuhashini Malia, what do you think?
So the thing is, it's not just the angles that matter. I just wanted to ask if you can reflect a triangle, and if reflecting a triangle would make it superimposed on another triangle, and those two triangles would still be similar.
Okay. Taran Kumar, what do you think?
With regards to the triangle or the ratio of areas of similar triangles?
So my question is, someone told me that, oh, similar triangles, that means corresponding sides are proportional. Someone else told me, oh, similar triangles, that means they are equiangular. I'm asking,
both of them
are these two concepts same? Like if the corresponding sides
both of them can both of them can hold true, because an angle can remain same, however the sides can be in sides can have different units, and therefore the proportion remains the same because of the angles in the triangle remaining the same, whilst the sides are also changed. So both of them hold true at the same time for similar triangles. With I also have another theory with regards to the ratio of areas of similar triangles. So in this case, because we know that the sides are proportional, therefore it would also be safe to say that the square of the sides are proportional in terms of their area, right?
Okay, that's where we are going at. Absolutely, you're right. But let me just make a remark before I move on to that point, that this has been a consistent point of confusion among students of all classes. Actually, these two statements are equivalent and one can prove it. So if you can show that if corresponding sides are proportional, then the triangles would be equiangular. And if the triangles are equiangular, then the corresponding sides are proportional. So they speak about the same thing. But I will not spend time today explaining why that is true, because I want to do some interesting problems. But you should definitely spend time thinking about it, because these two are different sentences. corresponding sides are proportional and the triangles are equiangular. They are different sentences, but one of them means the other and vice versa. But you have to prove it. You have to rigorously prove the fact. Otherwise, you cannot accept it. Okay. But given that, suppose we accept it for the moment, if we accept it for the moment, then the question comes, what is the ratio of areas of triangle ABC to triangle XYZ? What is the ratio of areas of triangle ABC to triangle XYZ? So as Taran was rightly pointing out, that the ratio of areas is square of the ratio of corresponding sides. So you take two equal angles, take the side opposite to them, square the sides, so you get AB square and XY square, and you take the ratio. That is the ratio of area of these two triangles. My question is, why? So can any of you tell me why this is true? Why is it true that the ratio of areas of similar triangles is equal to square on their corresponding sides? I'll give you a hint. Okay, Taran Kumar has a raised hand. Let's wait a little bit more and wait for others to think about it for a moment. So if you drop a perpendicular, because if you have to compute the area of a triangles, then you better drop perpendicular, right? So you drop perpendicular from C and Z. Let's call that T and Q. So what is the area of triangle ABC? Area of triangle ABC is half TC times AB, and area of triangle XYZ is half ZQ times XY, half base into height. So TC is the height times AB is the base, and ZQ is the height. ZQ is the height and XY is the base. ZQ is the height and XY is the base. So you have these two products. So I can cancel off the half. I'm very close. There are two other similar triangles created in this picture. Can anyone tell me what is that?
BTC and YQZ.
Okay, with raising of hand, but yes, you're right. BTC and YQZ. Why is that? Because 90 degree equals to 90 degree, and this angle B was always equal to angle Y, because the two original triangles were similar, and the remaining angle is just 180 minus these two. So these two triangles are equiangular, therefore they're similar. So triangle BTC is similar to triangle YQZ. Now we know if the two triangles are similar, corresponding sides will be proportional. Corresponding sides will be proportional, right? So can anyone tell me what is TC over QZ equal to? What is TC over QZ equal to?
BC upon YZ.
Okay, Rishabh Siddharth is right. TC upon QZ are two sides opposite to equal angles. So their areas, ratio of their areas is equal to the two sides, ratio of two sides opposite to 90 degrees, which is BC upon YZ. But remember,
Good evening, sir.
yeah,
I joined a little late because I was busy with some other work. Could you recap what's done?
I cannot, because it's a limited
Okay.
time. Please try to follow along. Okay. All right. So TC upon QZ is equal to BC upon YZ. That is fine. But what is BC upon YZ equal to? Can anyone tell me that?
So AB upon XY, sir.
Is equal to AB upon XY, because the original two triangles were similar. So this is equal to AB upon XY. So what we just did is that we had TC upon QZ here, and we know TC upon QZ is equal to AB upon XY. So we will just replace it by AB upon XY. So now we have AB upon XY times AB upon XY is equal to triangle ABC divided by triangle XYZ. So that is AB square divided by XY square. So that's exactly what we tried to say, that if two triangles are similar, ratio of their areas is square of the ratio of the corresponding sides. That is something that we wanted to show. Okay, so these are two facts about ratio of areas which are very handy, and you can use it in a variety of problems. And one of the problem that we would like to use it is what happens inside. So this is sometimes I call it 3 magic triangles. It's a very important configuration when you are doing geometry, either for mathematical Olympiads or for ISI-CMI entrances. You have to know certain configurations that come up over and over and over again, and this is one of that particular configuration. There, given a triangle, there are 3 pieces of triangles inside it which have a variety of use cases, and I will show that. They are related to Shavians. So what are Shavians? So if you have any triangle, let's say ABC, a Shavian is a line segment connecting a point, a vertex, to a point on the opposite side. So you take a vertex, let's say A, any vertex, you could have chosen B, and you draw a line connecting A with some point P on the opposite vertex, opposite side. This segment is known as a Shavian. Now we know certain special Shavians from our school geometry. Can any of you tell me example of a special Shavian that you have learnt about? Let's go to Nirjhar Sarkar.
So the altitude, the median.
Okay, the altitude of a triangle, the medians of a triangle, they are all examples of Shavians. They are special Shavians. Okay. Angle bisector is also a Shavian. Yes, that is correct. So what I'm going to do is I will draw 3 Shavians which are concurrent. P, Q, concurrent means they pass through the same point. They pass through the same point. Let's call this point T. So we have ABC, a triangle. We have 3 Shavians. We have 3 Shavians passing through a single point. Now, as some of you have rightly pointed out, that you can use this to prove the Shaver's theorem. Yes. But I'm not really interested in Shaver's theorem at the moment. I'm just going to use this in a different way. So let's see how. One of the thing is this, that if you look at this particular picture, you can immediately, it's actually using the idea of proof of Shaver's theorem. So it's not, I'm not going to go up to Shaver's theorem, but I'm still going to use the idea of proof of it.
Sir, I have a question, sir.
Yes.
But AP is the angle bisector, right, sir?
No, it's not. It's a random Shavian.
Okay. But
yeah.
But then, so it's given about that angle bisector. So can you like say which if there's any angle bisector in this diagram?
Angle bisector is a special Shavian.
Okay.
And here we are not talking about the angle bisector.
Okay, sir, I understand.
We are talking about any three Shavians. The only condition is that they intersect at a single point T.
Okay, sir.
Okay? They
Yes,
intersect at a single point T. All right. So now that we understand this much, let us focus on these two triangles, ABP and ACP. Triangle ABP and triangle ACP. Okay. So you can find the ratio of the areas of these two triangles. What is the ratio of areas of these two triangles? Can you tell me, any of you, with a raising of hand? ABP and ACP. Remember the configuration that we talked about. P is the vertex, one vertex, two triangles with the bases on the same line. Okay, we have a plenty of raised hands. So let me go to Mohak Chug.
Yes, sir. So this would be BP is to CP.
BP is to CP. You are absolutely right. Because they have the same vertex, their bases are on the same line, and the two bases are BP and CP. So the ratio of areas of ABP and ACP is BP is to CP. Absolutely right. So what is there are two other triangles whose ratio of areas is also BP is to CP. There are two other triangles whose ratio of areas is also BP is to CP. Okay, Bhuvan Chauhan, tell me which two triangles are those?
So triangle ATQ and triangle QTC, and similarly triangle ATR and triangle.
Wait,
okay, we can see
no,
about
it's not
AQ
right.
upon QC. Sir,
Advik Agarwal, could you tell me?
Sir, triangles PTB and PTC.
Triangle PTB.
Correct.
And triangle PTC. Absolutely. PTB and PTC. These two triangles. Those two triangles have the same vertex T. Those two triangles have the same vertex T and the same base BP and PC. Okay, so far so good. Now I'll just recall a principle of mathematics that we have learned in middle school. And that principle is this: if alpha by beta equals to gamma by delta, then both of these ratios are equal to alpha minus gamma divided by beta minus delta. And you can check that this is true. If 15 by let's say 25 by 20, if 25 by 20 is equal to 5 by 4, which is obviously right, then both of these ratios are equal to 25 minus 5, divided by 20 minus 4. So that is equal to 20 by 16. So this is very easy to prove. The basic idea, I'm not going to prove it, but the basic idea of this proof is that you take this ratio equals to some k, you assume that it's constant, and then you write alpha equals to beta k and gamma equals to delta k. Now if you subtract and divide by beta minus gamma, you will get beta minus delta, you will get the result that you want. I'm not going to prove that entire thing, but you can easily try and prove it yourself. Anyway, the point is this, that BP over CP is equal to this ratio, that's equal to this ratio. So that's equal to, can anyone tell me what we get? Okay, Divyansh Arora, go ahead.
So it will be equal to, sir, am I audible? It is equal to the ratio of ATB is to ATC.
ATB is to ATC. You are absolutely right. ATB is to ATC. You can just take the subtraction. This is ABP minus PTB, that is ATB. This big triangle minus the small triangle is ATB. And this big triangle minus the small triangle is ATC. So you have ATB over ATC, and that gives you two pieces of the three magical triangle. This red one, this blue one, and this green one will be the other magical triangle actually. So it's very important to keep this configuration in mind, that this particular triangle ABT by ACT, that's ratio is equal to BP over PC. BP over PC. Now using this particular strategy, we can also show that ATC, triangle ATC divided by triangle BTC, that means blue by green. Blue by green is how much? Can anyone tell me what is blue by green? Blue by green. Okay, let's go to Nasir Ali. Nasir, tell me what.
It's equal to AR over RB.
AR over RB, absolutely right. Very good. So we understand the idea. So the red triangle, I call it the RBG. If you are into computer science, you have probably encountered the word RBG. It's a color gamut. Color palette.
It's
Yeah.
RGB, I think.
Sorry?
Sir, I think it's RGB.
RGB, correct. So anyway, so I keep this mnemonic in my mind to actually keep this configuration in my mind, and it's so useful. And recently a problem came up, I think in the ISI entrances and only, but it can as well be a very useful problem for mathematical Olympiads that uses this particular principle, and it's very beautiful how they actually use it. So the problem was like this, and I'll give you the problem. Maybe you've seen the problem before, maybe you have not. The problem was like this, that if you have a triangle ABC, so it's ABC, you have a triangle ABC, and you draw two Shavians. So you draw two Shavians, one is BD and one is CE, and any two Shavians. You draw any two Shavians, and you sort of mark the areas of the different regions that you have produced. You mark the regions that you have produced. So area of this part is X, area of this one is Y, this triangle is Y, area of this one is Z, and area of this one is W. This quadrilateral is W. Okay, turns out that you can write W, you can express W in terms of X, Y, and Z. It's possible to express W in terms of X, Y, and Z. I'll give you a minute to think about it and tell me why that is true. How can you write the value of W in terms of X, Y, and Z? Give it a try, all of you. Think about it. This will be a bit more challenging than the material that we have done so far. And that's all right, because it's supposed to be challenging. Otherwise, it's just a school geometry seminar kind of thing. So it's supposed to be a bit more challenging. That's all right. But think about it. And if it helps, and I think it does, you can actually draw, so let's call this point M. You can draw the other Shavian. And you can call this Y1 and Y2. So you know Y1 plus Y2 is Y, and you know the value of Y. And this is W1 plus W2. Doesn't help much because you do not know W1, you do not know W2, and you do not know W1 plus W2 either. But that's all right. You don't need that. So think a little bit more, and then I will talk to you about this problem. The fun part of this problem is this, that all you need is all I have discussed. You do not need any fancy formula. The techniques that I have talked about, the method that I have talked about, you just need those things. That's all. Okay, Bhuvan Chauhan, go ahead.
Sir, I haven't as of now thought of the complete answer, but I'm able to see something in this question. That is, if we basically mark the Fabian suppose AQ, the point on the base as Q.
Okay.
So basically, if we see the triangle BMQ and triangle QMC, so basically we can say that BQ upon QC equal to Y1 upon Y2.
Okay, BQ upon QC is Y1 upon Y2. That is correct.
So this is the ratio, but we can also observe one thing, that is if we see the triangle ABC completely and the Sabian AQ. So basically we can add up the areas, that is Y1 upon X plus W1 and then W2 plus Z plus Y2. So we got the ratio of the sum of the areas.
Sir, I got the answer.
BQ upon QC.
Okay, let's see. I mean, maybe Bhuvan, you can write a bit more and then come back to me.
Sir, I got it.
Okay, Raghav has the answer. So let's wait a little bit more, Raghav. Okay, maybe Raghav, you can tell me what your answer is, how you found it.
Yeah, so it actually goes like this. So we know that firstly that W by 2 plus X.
Wait.
Wait.
That's not W by 2.
Sorry, W1. Yeah.
W1 plus X, okay.
I think we can go this way. W1 plus X
Okay.
upon W2 plus Z.
Okay.
Now this will give us Y1 is by Y2, right?
This is y1 by y2. Yes.
Yeah. Now what we can do, now we can cross multiply.
Cross multiply. Okay. Okay.
Right. Now since we cross multiply, and now then so actually what problem did I do? I just assumed it as Y by 2, so that's why
Okay.
I'm into some mess.
So that's fine.
But
Okay. Keep on working. Keep on working. That's fine. Keep on working. Shaurodeep has an idea. Okay, go ahead, Shaurodeep.
You can take it in this way, as the base is AB with the Sabian meeting CE at like CE at E. So W1 by X will be same as
W1 by X is equal to
yes W1 plus W2 plus Z by X plus Y1 plus Y2, which is same as W plus Z by X plus Y.
W plus Z divided by Y.
Yes, yes.
This triangle by this triangle. Okay.
Yes, and similarly, you can uh, do W2 by Z is same as X plus W1 by Y.
W2 by Z. Okay. W2 by Z equals to
X plus W1 by Y.
X plus W1 by Y. Okay.
So I can, from the first equation, I can take X to the right hand side and Z from to the right hand side in the second equation. I will get W1 and W2.
So YW1 equals to XW2 plus XZ, and YW2 is equals to XZ plus ZW1. Okay.
Yes. So
Think a little bit more. It seems you may need to think a bit more.
I will try it.
Okay. Okay.
Sir, I have an idea, but I don't know if it will work.
Okay. What is your idea?
Sir, if we connect ED and then label instead of W1, W2 like that, we can write W1, W2 above and below, thus creating two similar triangles AED and ABC, and then
It will be very hard to create similar triangles because even if you join ED, I mean, I could join ED, that's fine. It's not necessary that AED is similar to ABC because we don't know whether they're parallel to each other.
oh yeah.
So, Bhuvan, what is your idea? Okay. It seems all of you are kind of stumped. All you have to use is the stuff that we have talked about. You don't even have to use the similar triangle thing that I have talked about. because there is no similar triangle here. So I have given you a redundant piece of theory.
Sir, can we directly do using Sevastvaram?
I don't know, you tell me. I am pretty sure that all of you know everything that is necessary to solve this problem.
Sir, we could use the area ratios, sir.
Use it and tell me what to do.
Sir, I actually joined late by 30 minutes. I couldn't find the link. So could I get the recording of the session, sir?
Yeah.
Can you once explain what is W?
Sorry?
What is W in the question?
W is the area of this quadrilateral. That's what W is. W is the area of the quadrilateral.
So since I joined late, will the link be available in the group, or like for the recording of the video, will the link be available in the group, or
Yeah, it is posted in YouTube actually.
okay, thank you.
হাঁটতে বেরোলাম, এই চাবিটা আমার কাছে থাকবে, আরেকটা আমার কাছে। তোমরা খেয়ে নিয়ে এসে আমি একটু হাঁটতে হবে না, আর এই যে এখানে জল আছে।
Sir, I joined late, so can you tell me what information is given in this question?
The only information that is given that ABC is a triangle, CE is a Shavian, a line connecting C and any point E on AB, and BD is a line connecting AC and B and a point, any point D on AC. There is nothing special about C and BD. There is nothing special about them. And it's given that the area of this triangle EMB is small x, DMC is small z, BMC is small y. So I've split it into two parts, y1, y2. And AEMD, this quadrilateral, is W. Area of it is W.
So what is a Savian?
It's just a line connecting a point to the opposite side, a vertex to the opposite side of the triangle. Yes, Vrajishnu, go ahead.
Sir, am I audible?
Yes, you are.
Sir, so my idea is that we take the triangle CEA and CED and we get the relation that W plus Z by X plus Y is equal to AE by EB.
W plus Z.
Right. Yes, sir. W plus Z by X plus Y.
Okay.
That is equal to AE by EB.
That is correct.
Now, I have this idea, like, let us assume that this is some constant K, constant ratio K.
Okay.
Now that K can be like any positive integer, even any positive real number. I have come this far now. I assume that like we can express W in terms of X, Y, Z, but then a K redundant factor is still there, like an extra.
Yeah.
So like, sir, I cannot give an exact relation.
So you have to think more. Okay. What about you, Gaurav? I see a raised hand.
Yes, sir. I just had one question.
Uh-huh.
would x y1 plus y2 and z be in a ratio?
In a what? Sorry.
They would be proportional. They would be similar, right?
Why?
Because bm is shared between x and y.
They will not be similar.
Okay.
I mean, they may not be similar. I'm not sure. I mean, in some triangles and some cases they might be similar, but in general, that's not the case. Yes, Shaptorshi, go ahead.
Hello, sir. Am I audible?
Yes, you are.
So I have a relation between x, y, and z in terms of the area of triangle ABC.
Okay.
So
What is it?
further, we can get it from W also.
Okay. Tell me how to do that.
Okay, so what we do is we draw perpendiculars from the line BC, from B and from C.
Okay. Let's draw perpendiculars.
No. So like perpendicular to B, perpendicular to BC,
Perpendicular to BC from which point?
from B and from C. Like we just draw a line.
I cannot draw a perpendicular. Oh, you want me to draw like this?
Yeah.
Oh, okay. Okay.
Okay, and then we actually extend the sides CE and BD to the perpendiculars.
Okay.
And we actually also need to do that for AB and CA, like BA and CB.
So you want me to draw perpendiculars like this?
No, I want you to extend the line BA to the perpendicular that we drew. Like there's no space to do that. But
BA to the perpendicular. Oh, I see. Like this.
yeah,
Okay.
yeah. Okay, and same for CA, but on the like other perpendicular.
Okay.
Yeah. Yeah, so now basically we have this property like when there are like three like lines like that. So basically one by the height of that line plus one by height of the other line is one by height of like the third one.
So can you tell me which triangle you're talking about?
Like let's consider, yeah, like can you mark those points here?
Okay.
So like yeah, so basically like triangle RA, like RBC, if you consider like triangle RBC and triangle HBC or something.
RBC and HBC.
Yeah.
Okay.
So we have like call HB as some H1 and the other one H2.
Okay.
And call the line like MQ as H3.
MQ is not a perpendicular, by the way.
Okay, no, then like make a perpendicular. Uh,
Okay.
yeah, so then we'll have like 1 by H1 plus 1 by H2 is equal to 1 by H like 3 if you call that H3.
Why?
It's similar triangle. So triangle RA, like a triangle RAB and triangle
R.
M
Hold on. R.
RA, sorry, RBC.
Okay.
Triangle RBC.
Uh-huh.
Wait, just a second.
Okay.
triangle RBC will be similar to. Can you just hold on for a second, Leah? I'm
Yeah,
just looking at my.
those of
Yeah.
you who are trying, this can be done without this construction. So I'm sure Shaptarshi has an idea. Something can be done with this construction, but it can be done without any construction. Yes, Mohab, go ahead.
Okay, so I have an idea. So basically, so we know that W1 over X equals W2 plus Z over Y.
Yes.
Right. So we get that W1 equals XW2 plus XZ over Y. Just taking X to your side.
W1 equals XW2
Hmm.
plus XZ over Y. That is correct.
Yeah. And similarly, W2 equals ZW1 plus XZ over Y.
ZW1 plus XZ over Y. Yes.
Hmm. Now we can add these two, and so
Let's
on the left
add these
side.
two.
Hmm.
Okay. So W equals to XW2 plus XZ plus ZW1 plus XZ by Y.
Hmm. Right. And so originally we had this equation, right? W1 over X equals W2 plus Z over Y. Right. So can you write that one down?
W1 over X equals to,
W2 plus Z over Y.
yes,
Yeah, and the other one as well. So W2 over Z equals W1 plus X over Y.
okay,
Yeah. So now we can add these two as well. So this, yeah,
okay.
yeah, by taking LCM on the left side.
W1 by X plus W2 by Z equals to W plus X plus Z by Y.
Hmm. So we can just take the LCM on left side. So we get W1Z plus W2X
Yes.
over XZ. And now we can take XZ to the other side.
Okay, so W1Z
Hmm.
plus W2X equal to XZ times W plus X plus Z by Y.
Hmm. Yes. Now this value of W1Z plus W2X, we can substitute in the value of W we got.
Excellent, very
Hmm.
good. So we just substitute this by this quantity.
Hmm.
So what we get is W equal to 2xz. You have 2 times xz, this quantity, plus xz plus x plus z by y divided by y.
Hmm. And now what we have to do is like isolate Y from the other side. Sorry,
Isolate,
W from the other
you
side.
can just isolate w because
Yes. Yes.
that's what we want to find out.
Hmm.
Excellent. That's exactly what we have to do. And that's all.
Hmm.
If we just do this, we can get the final value of W. And I can do the calculation here. I mean, that's fine. We can all do the calculation. But since time has been extended a bit more than I wanted it to, so I will not do the explicit calculation. But if you do it, you will get the final answer. And if you are in the WhatsApp, one of the WhatsApp groups that we have, you can definitely go ahead. And Shaptarshi, if you are in that WhatsApp group, you can definitely put your solution there too. It seems interesting what you had to say, but
Yeah.
we are out of time, so I'm not able to take your solution at the moment.
Yeah. No problem. No problem.
Okay, but thank you for that. But now I'll just take questions from students who are here or parents. If you have any questions related to any of the contest or anything else, please ask me right now. You can just uh, raise your hand and ask the question. It's fine. Any question, anyone, students or parents? Okay, so that is kind of interesting because all other sessions had questions. That's good. No one has any. Okay, so I see. Someone is raising hand or not? Maybe not. Okay, Rajishnu, go ahead.
Sir, I have this very weird question.
Okay.
Are there Olympiads after 12?
There are mathematical Olympiads after class 12 for college students. For example, in India, there is Madhava math competition, but there is also a international math competition like Putnam for students in US and other countries can also participate. But to be very honest, not all of them are held in as high regard as the mathematical Olympiads at school level. So instead, what we suggest students who are in high school or who have just passed out of school is that focus instead on research projects instead of trying to do Olympiad mathematics. That
Sir, research projects like
yeah, so you can learn something that is so creating knowledge is a very interesting profession, and researchers like in mathematics, physics, computer science, and other subjects, they are interested to know new things which have not been known earlier. Now, how do you go about doing it? So Chinta itself has several research groups. The basic idea is this: you start working with a professor or a researcher on a particular area of mathematics. You
So
learn.
are there any available researchers currently?
Sorry,
Are there any like open researchers currently?
we just started one about a couple of months ago, 1 month ago on hyperbolic
What is it
geometry.
about the topic, sir?
It was on hyperbolic geometry, but I think that admission to that is closed now. We
Okay,
already
sir.
have taken all the students that we can. But if more research projects come up, we will definitely inform the students in the WhatsApp groups and other places. But at the college level and university level, or even at the high school level, after you have passed high school, I strongly suggest that instead of trying to get pleasure from Olympiad styled problems, you can think about getting pleasure from a more deeper challenge, that is create new mathematics. Okay, so that is very interesting in itself. Okay, Prachi Mishra, go ahead.
Sir, is there any books that you can suggest for higher level thinking of mathematics, like Olympiad or
You're in which class, Prachi?
10th currently?
Then the first, and you have not done any Olympiad style stuff before.
I've given Olympiad in ninth grade, IOQM in ninth grade.
Okay, so for you, I would say that you should focus on only one book, that is Challenges and Thrills of Pre-College Mathematics, and try
All
to
right.
get it done cover to cover before wandering into the big beautiful world of other books and other websites and other places where you can also do some wonderful stuff. But the trouble of doing too many books and too many resources at one shot is that you run into the trouble of doing a lot of things but not really accomplishing anything. So focus on one book, get it done, and then move on to other material. Okay.
Yes, sir.
Okay.
Thank you.
Toshi, you have a question?
Yes, sir. What other Olympiads should we give except IOQM? Like, I'm in 10th right now, so.
So only focus on IOQM, but if you have to give other Olympiads, depending on what your goals are. For example, some
Yeah.
students are interested in going to, let's say, United States or Canada or UK for higher studies. If such a thing is in your goal list, then you can also take American Math Competition 10, and
MC.
University of Waterloo contests are also really good. But really, one can just focus on IOQM and forget about everything else, and try to get done up to INMO at least within a couple of years. That should
Okay,
be the
sir.
standard goal. Okay,
All right.
Aryan Dash, go ahead.
Sir, I really wanted to ask one thing, that geometry is like one of those topics in mathematics that requires such deep understanding on also some constructions that sometimes do not click to us. So what can we do so that those constructions click to us and also we can get more confident about geometry?
Yeah, I have thought about this question quite a lot, that how can you think about the extraordinary constructions that some other students do or some teachers do, and they seem to come out of nowhere, right? uh, the only good answer that I have is that you have to see other teachers and students perform those things over and over again in front of you in the form of a class or a discussion group. And the more exposure you have, there is a better possibility that those things will start coming to your mind. One of the things that I suggest to the internal students is that you should take the 5 days a week problem solving session if you are part of IOQM group or the ISI-CMI entrance group, because in those 5 days a week problem solving, every day you are seeing new problems, you are thinking about new problems, and that is very very important, because every problem is different and every problem has its own challenge, and every problem has a new construction, a new idea. The more you see, the more you are exposed to such things, the better possibilities, the better chances are that it will click to you. I'll tell you one analogy. Most music teachers, people who teach vocal music or instrument music, they will tell you that 80% of learning music is hearing other people's renditions, either other vocalists or other instrument players and so on. 80% is listening. 20% is your own practice and rewaj and everything. So that is this is the rewaz of mathematics. You see every day new things happening. You see every day new ideas being sort of exchanged, and that is the only way. There is no other way. Okay, Mukunda Bharadwaj, go ahead.
Thank you, sir. Sir, could you recommend some books on physics problem solving, sir, and also how to get into the physics programs, sir?
So it is better to ask Kazi sir, who takes the physics classes at Chinta. Uh, there are several books that he has suggested. If you are in one of the WhatsApp groups at Chinta, you can post it there. Post your question there, and I'm sure Kazi sir will respond with a set of books. Okay.
Sir, how do you enroll for the physics program, sir?
Oh, you have to just take a couple of trial classes in physics, and you can ask the admin to give you access to that. If you like the trial classes, then you can join it. The main idea is that the physics program at Chinta is problem focused in nature, in the sense that we assume that you have learned some physics in school and other places.
Yeah.
You are coming to us for interesting and challenging problems. That is the main goal of our programs. So you can go ahead and ask the admin and they will help you. Okay.
Okay. Sure, sir. Thank you.
Nasir Ali, go ahead.
Hello, sir.
Yes.
When I'm taking a math Olympiad, I usually find the geometric the problem hard to solve. So I like I avoid it.
Yeah.
So it's like IMO stuff or something like that. So can you suggest me books to read or classes to take to get better in geometry?
To be very honest, Nasir, I mean, classes can help, of course, and you can definitely go to our website and apply for classes that we have. But I will tell you something that I personally do, okay? And that has been very helpful for me. what I do is I carry a small notebook. This is called my little notebook. I call it the Ramanujan notebook just for fun. And I always keep a couple of geometry problems in there. And wherever I am, I'm actually scribbling some diagrams on those problems until they get solved. So in a way, I started living with the problems. So I would strongly suggest that you do that. That's a sort of a habit that you can grow. That's number one. Number two, to get started with some really nice geometry, you can take help of couple of books. So one of the books that I suggest all the time is Kiselev's Planimetry. So I'll just write it in the chat again. That's a very nice book. Kiselev's Geometry, Planimetry. And there are other books that you can use which are really beautiful. It will expose you to the depth of the subject. One of them is by Yaglom. It's Geometric Transformations, volume 1 to 4. So that's also a very beautiful book. And finally, the last book that I will suggest, if you really are like what you want to develop a fascination for the subject, there is a book called Lines and Curves by Vasiliev. You can try that book as well. Okay. So
Okay,
I
thank
think
you,
these
sir.
will help. Divyansh Arora, what's your question?
Okay, sir. My question was like in regards to research mathematics. I wish to pursue a career in research mathematics, especially number theory. But like sometimes, like I feel like what exact path I should go forward with. Like I'm working on Olympiad mathematics. I'm trying to improve. Uh, but like how well does Olympiad mathematics connect with research mathematics options in the future?
So you're in which class, Divyansh?
So 11th.
11th. Okay. So there are couple of things that Olympiad maths do. The first thing is it sets up a mindset for solving problems. Maybe you have observed this before, that if you try to do school problems, they are repetitive in nature in some sense. And when you try to do Olympiad problems, they may take a lot of time to actually get solved. So that is actually true about research. Only the difference is, while the Olympiad problem can get solved within a couple of hours or a span of 7 days, a research problem usually takes years to solve, maybe a couple of years. So it's research in miniature, you can say. And that is one way Olympiad problem solving actually helps you to get an early taste of what is about to come. But and it's an important skill to be to able to do that. The other thing that is very important that Olympiad math does is that it actually helps you to go to some of the best universities in the world and do mathematics. If you are qualified in INMO, I strongly suggest you try for um, ISI or CMI inside India, or the universities abroad in US, in Canada, in United Kingdom, and you try to work with people like Terence Tao. I mean, how what can be better than if we can work with such people, right? So we can learn a lot from them. And one of the ways you can reach those universities is by doing really well in the mathematical Olympiads and then showing that result to the universities and telling them, okay, you see, I am so good at this sort of mathematics. I want to learn more. Can you let me in? And that is a very good gateway for these great places. Mathematics is seldom done alone. Some people sometimes do it. There are stories of that. that a lonely mathematician doing wonders. That has happened. For example, Perelman, maybe you have heard of him. Uh, Grisha Perelman solved the Poincare conjecture, and he probably worked pretty much alone. And there are some other examples. But in most cases, you would need other mathematicians around you to talk to communicate, to exchange ideas. I'll tell you this much, that even in our small office of Calcutta in Chinta, we have the faculty members are here, and most of them are actually engaged in research. Uh, and we have a nice communication at, like, in between lunch when we are walking across each other's office and so on. So that is a way of doing this thing. Okay, so you can use Math Olympiad results for that. Okay, Bholanath Bhomik, go ahead.
Sir, so when is this year's IUPM dates, sir?
It's probably in the end of October, like last year.
Okay, sir.
Okay. All right. Thank you. Okay. Bhuvan Chauhan. Okay. Last question, maybe. Yeah.
So my question is like very small. It's that it's math something like really connected with someone's IQ, or it's more about practicing a subject and getting to know maths like every day and different concepts.
I mean, I do not know what is IQ actually. I do understand that, what I do understand your question, but for me, it's like music, you know. Just like I enjoy music. When I'm listening to music, think about it.
So basically an art.
When you are listening to music, or you are singing it in the bathroom, let's say, okay, you're singing on your own, you are not really worried about the fact, am I really good at music? Am I a great vocalist? You're not worried about those things, right? You're just enjoying the music. For me personally, mathematics is like that. That I enjoy doing it. Am I really good at it? Who knows? I'm good. I'm better than some people. I'm worse than some people. So I'm not really interested in that race. What I am interested in is that at the end of the day, when I'm sitting in a cafe, or when I am sitting in my office, or when I'm just laying in the bed, what is it that keeps my mind busy, and what is it that I like to think on? I'd like to think on a problem. Maybe I don't understand how to solve it. Maybe I'm not good enough to solve it, but still I'm engaging with the problem and I'm liking it. And that is for me enough to be able to do mathematics. So I don't think you should worry too much about IQ or any other things. The only thing you have to worry about, do you enjoy it or not? If you enjoy it, then do it. Very few people actually enjoy doing anything. People just do things because other people tell them to do those things. If you are enjoying something and doing it, that is very good. That is what you should be aspiring for. Okay.
Yes, thank you for the answer, sir.
Yeah, sure. Any other question? Okay, so that's it. Thank you everyone for joining in today. I'll see you in the next seminar. Okay, bye. Take care.
So when is the next seminar?
We will